Hey guys, I hope you guys are being healthy at home and safe at home right now. We are about to go over lesson 5 for surface area, and this is actually going to be your last lesson for this school year. So, congrats if you've made it this far. I know NTI is something that took a lot of getting used to, but I think a lot of people are doing a great job. So, what we are going to do is first we need to make sure we have our name. So I'm Miss Peck. We have our date, which the date that this should be completed is the 20th. So 5/20/20. And then the period that you are in, which I am a teacher, so I don't have a period. And then our title today is going to be How Can We Use Surface Area to Solve Problems? So we're going to use surface area to solve real life problems and applying it to real life situations. So our first question that we have here is the cereal box shown at right is cut from a piece of cardboard with 600 square inches. How many cereal boxes can be cut from this piece of cardboard? So no matter how you are taking notes today, just notice that I've kind of underlined important parts that we'll need for the next section. And I underlined that we have a total of 600 square inches. And then how many cereal boxes can be cut from this piece of cardboard. So here's our cereal box over here. And what we have to do is we have to find the surface area of this one cereal box to see how many cereal boxes can we make from the cardboard that we were given. So what we need to do first is we need to put what we know and what we need to know. So we know, and we're going to write this in blue, and I'll scoot it up a little more so we can see it. We know that this cardboard is 600 square inches. So we have 600. That is not the prettiest. So I'm going to go back. Okay. So we have, let's see, 600. There we go. Come on. 600 square inches of, and I'm just going to put CB for cardboard. And I'm not sure why it's not working right now. So give me just a second. It's just being slow. 600 square inches of cardboard. So CB for cardboard. Okay. So we know we have 600 square inches of cardboard. And what we need to know is how many cereal boxes can be cut from this piece of cardboard. So we need to know the number of cereal boxes that can be made. So I've already set up how we're going to work out our problem down here. So what we are going to do is we are going to split the cereal box into 3 separate sections for area. So if we look, and let's get our page a little smaller. So if we look here, we've got our total surface area, which is what we're looking to calculate. And then we've got it broken down into 3 separate sections. So we have our first area, our second area, and our third area. And the reason we do that is because we know the total surface area will be covering the entire box, but we know that the front of the box and the back of the box have the same area. The left and the right sides will have the same area because they are the same size rectangles, and the top and the bottom will have the same area. So we're going to go ahead and do that. So let's do our first area we know is going to be, we'll do the left and the right triangle. So it is length times width for that area for one of them, and that is 12 times 2. So over here, we are going to write 12 times 2. Okay. And then we know 12 times 2 is 24. So we're going to write 24 right here. But we also have to multiply 24 times 2 because 24 is the area for one of these triangles. But we have two of them. So we're going to multiply that by 2. And 24 times 2 is 48. So that is our first area. So we'll do our second one. Our second one, let's do the top and bottom. So length times width, we've got 8 times 2. So we're going to write that in where it says A2. 8 times 2. And so 8 times 2 we know is 16. So we're going to write that on the second line. But we know we have to multiply this by 2 as well because we have not only the bottom one, that's 16 squared, 16 inches squared, but we have the top one that is also 16. So we need to multiply that by 2 because we have two of them. So 16 times 2 is 32. Okay. And then our last area, which we've done the right and the left, the top and the bottom. So now we need to do the front and the back. So our front is 8 inches by 12 inches. So we'll do 8 times 12. Give me a second because it's loading. And 8 times 12. There we go. So 8 times 12 we know is 96 inches. So we've got 96 we need to write right here. And then we also know that that's only the area for one side, and we have two. So we need to do 96 times 2, which gives us a total for that part as 192 square inches. So now we have our three areas and we can calculate the total surface area. And all we have to do that is to put all of them together. So what we'll do down here is we will do our surface area, and to show is equal to 48 plus 32 plus 192. And when you add those three together, we find that our total surface area is indeed 272 inches squared. So we'll put up here where it says total surface area, 272. That's not the prettiest. So we'll undo that one. So it is 272. And then because we're using inches, you have to make sure that it's in the right form. So we'll put inches squared. So we found the total surface area of one cereal box, but we have to know how many of these cereal boxes can be made with 600 square inches of cardboard. So what we are going to do is we are going to go over here and we are going to write that we can, solution is that 2 cereal boxes can be made. So the reason we know that is because 272 is almost 300, and 300 goes into 600 twice. So that means the total number of cereal boxes that can be made is 2 out of the 600 square inches of cardboard that we were given. So I'll give you a second if you would like to pause on the screen and write this. So if you would need to write the answers here, pause here and then you can write those. Or type if that's what you're working on. So now we are going to skip down to this one, and we've got a shoebox. So same process as before, except we are doing a shoebox instead of a cereal box. So a shoebox is covered with packing paper before being shipped. The paper costs 1 cent per square inch. How much will it cost to cover 3 pairs of shoes? So what do we know? Well, we know that the paper cost 1 cent per square inch. So we're going to write in here paper cost and it's 0.010. So paper costs 1 penny or 1 cent. And that is per squared. Okay. And then what do we need to know? So we knew that the paper cost 1 cent per square inch, and we need to know how much it will cost to cover 3 pairs of shoes. So in order to figure that out, we are going to use our shoebox, but we need to know how much 3 shoes Okay, so how much 3 shoe pairs cost? So I've already set up down here how to solve that. So we're first going to calculate the total surface area, and then it'll also show us what the price is for each box. So let's make this a little smaller so we can see our shoebox. So just like before, we're splitting it up to our first area, our second area, and our third area. So our first area that we are going to do will be the left and the right. So the left and the right sides are 8 inches by 10 inches. So we know we'll do 10 times 8. And we know that 10 times 8 equals 80. But we also know that there are 2 sides here. So we've got the left and the right side, and 80 only is the area of one side. So we have to do 80 times 2. And 80 times 2 is 160. And then we are going to do our in the back. And so the dimensions for that are 16 by 10. So we'll do for a second. So we've got 16. I'm going to write out the number first, and then I'll do parentheses by 10. So we've got 16 multiplied by 10, which we know equals 160. And then we know that we have to multiply that by 2. So we're going to put this in parentheses and multiply by 2 because that is only the area of one side, and we have 2. We have the front and the back, and the total is going to be 320 if it would work. Okay, so the total is going to be 320. Excuse my bad handwriting, guys. The internet is very slow. So, and then we have our last area. So our last one is going to be top and bottom, which is going to be, okay, so this one was front and back, or top and bottom. This will be front and back. So front and back is 16 by 8. So we accidentally called this one front and back, but that is top and bottom. So front and back is 16 by 8 inches. So we would do 16 times 8, 128. And then we know we have to multiply this by 2 because we have the front and the back. So multiply by 2, which will give you a total of 256. So we know how to calculate total surface area now that we broke down this shoebox into 3 separate areas. So the way you calculate total surface area is we just add the 3 together. So we'll do 160 plus 320 plus 256. Okay, plus 256. And that gives you a total surface area of 736 inches squared. So it equals 736. And remember, we have to have inches squared. So 736 inches squared. So then the price per box we are able to calculate by knowing that each one of these 736 inches cost a penny. So that means our price for one box is, I'm not sure why it's doing this. So the price per one box is $7.36. So when we go to our solution, we found out how much one box would cost, but we need to know how much 3 pairs of shoes will cost. So in order to calculate that, we just take the price of one box and multiply it by 3. So we would do 7.36 times 3, and it's $7. And then that gives us a total for the 3 boxes of $22.08. So it is $22.08. So $22.08. And I'll leave this here in case you guys need to copy stuff.